Today we're going to go over section 1-8B. Yesterday we did reflections and translations. Today we're going to do stretches and compressions. So with stretches and compressions, I want you to be able to stretch or compress a function. So let's first define what a stretch and compression is. When you pull points away from the axes, so that means think of grabbing onto a function. If I take the function and I pull it away from the y-axis or I pull it away from the x-axis, it's going to stretch the function. So points that are pulled away from the axis is a stretch. Oops, I need a T in there. Points that are pushed toward the axis. So here we're going toward the y-axis. Here we're going toward the x-axis. So you can kind of see I'm compressing, making things smaller. This is called a compression. Now, if I want to do a stretch, I'm going to pull points away. So horizontally, if I pull horizontally, horizontal is along the x-axis, that's going to pull points away from the y-axis. And I multiply by a number that is bigger than 1. If it's 1, it's not going to change it at all. Now, if it's vertical, we need to change this here. We are going to pull, points are pulled away from the x-axis. Because what happens is you think of taking your hands and grabbing onto a function and pulling it this way. They're pulled away from the x-axis. So that is a horizontal. And I want to just give you a hint on x's and y's if you didn't pick that up yesterday. If you have x comma y, we need to make sure we understand that the horizontal is x and the vertical is y. So just put these in alphabetical order and then put horizontal and vertical in alphabetical order, and x lines up with horizontal, y lines up with vertical. Okay, compressions. A compression is when you push something together. So here a horizontal, if we want to compress horizontally, we're pushing that figure into the y-axis. So it's pushed toward the y-axis. If it's vertical, it's going to be pushed toward the x-axis, and we need to change this right here. We need to change this to push toward the x-axis. Okay, now compressions, you're going to multiply by a number that's between 0 and 1. So between 0 and 1, between 0 and 1. Okay, we want to perform a horizontal. So you need to take these apart. Horizontal means x. Compression means we're going to multiply. Now, in class, I told the students that transformations are all about, LT, location, location, location. Which means if you're affecting the x, it's horizontal. If it's y, it's vertical. And also about operation. Operation, operation. I'm just going to put OP for the next two. Which means that if you're adding or subtracting, it's a translation. If you're multiplying, it's going to be a stretch or a compression. If you take the opposite, it's going to be a reflection. Okay, so since this is a horizontal compression, we know we're dealing with the x, and we know we have to multiply. So we're going to take all of the x's, and we're going to multiply them by 1/2. So we have a -1. So again, you need to say what you're doing in all your tables, multiplying each x by 1/2. So -1/2, then we have 0, then we have 1, and then we have 4 times 1/2 is 2. Okay, now what I want you to do is scribble out this x so you don't accidentally graph it. All right, so now we're going to graph. We have negative 1/2, and we're going up to 3. 1, 2, 3. And then we have 0, 0. And we have 1, 2. And we have 2, 2. Okay, so now we can connect these points. Right here is a little curve. And then we go out like this. Okay, so you can see this is a horizontal compression, so think of the black one. As we push in like this, it turns into the blue. Okay, you have a U-try it underneath there.